equations or what? Quadratic equations and linear equations. And we were to look at this application question on quadratic equations. So the question says, the board of directors of Cheesy Company Limited agrees to redeem some of its bonds in 2 years. At that time, 1,102,500 cedis will be required for the redemption. And we were to suppose that 1 million is presently set aside. At what compound annual rate of interest will the 1 million have to be invested in order that its future value will be sufficient to redeem the bonds? So if you read this question carefully, you realize that this is something like compound interest with the initial principal being 1 million. And you are expected to redeem 1,102,500 cedis at the end of the 2 years. So that is what we have to do. The rate is not given, and it is that rate that the question is asking us to find. Okay, so we don't know the rate. The question says, at what compound annual rate? So we have to look for the rate. So this question last week, I remember telling you that I wanted to skip it because we'll be looking at interest. Then there is a simple formula that you can use to do it without any stress. But upon a second thought, we are not doing interest here. We are only applying quadratic equation to do this. So we are not going to use the simple or whatever interest formula, which is shorter. So if you have this question and I don't ask you to use any of the formulas, then you have to apply strictly, because we are applying what? Quadratics in solving this question, even though the question looks like an interest question, like compound interest question. You can only follow the formula of simple interest to do it, or compound interest to do it, but you are to apply quadratics in solving this, not just go straight and use the simple interest or compound interest formula. I don't know if I'm making a point here, but the principle here is an application of what? Quadratics. Application of quadratic equation in solving a compound interest related problem. So that is what we are doing here. So if I'll give you such a question, I will actually restrict you to use quadratic equations in solving it. Because if I don't restrict you, somebody will choose, we all like shortcut. So somebody will use the shortcut approach and solve. So if I'll give you this one day, I'll actually restrict you to make use of what? The quadratic equation approach. I hope I have made my point clear.
Yes, sir.
Good. So now let's look at the solution. So reading through this question, the principal is 1 million. And then the rate, we don't know. So we'll let the rate be R. We'll represent it by R. So these are the two things. Then we'll follow the compound interest approach in solving it. And then you see where the quadratics will come in, and then we'll apply the quadratics. So let's go. So see the solution. So we let R be equal to the annual rate of interest. Now, if R is the annual rate of interest, then at the end of the first year, excuse me, let me pick this call. Just 1 minute and get back to you, please. Okay, let's continue. So we let R be the annual rate of interest. Then if we are following the principle or the steps we use in solving compound interest, we solve year by year. So we have 2 years. So we solve for the first year. When we finish, we add the interest to the capital or the principal, and that becomes the new principal for the second year. Then we solve for the second year as well. So that is the steps we are going to follow. So at the end of the first year, the accumulated amount will be what? 1 million. That's the principal plus the interest on it. Okay, so that would be what? The 1 million plus, how do you find the interest? The interest is what? The percentage, that rate times the rate of what? The principal. So the principal is 1 million. Now plus the rate. So the rate will be 1 million, that's the principal times the rate for 1 year. You know, simple interest is principal times time times rate. So that will be what? 1 million, which is the principal, times the time. The time is 1 year, so times 1, times the rate, which is R. We don't know, so it is R. I don't know if you have followed. Do you get it?
Yes.
Please come again. Me, I don't get
Thank
it.
you. Thank you. Now, if you are solving simple interest, you say the interest, the simple interest is equal to what? Principal times time times the rate. Okay? When you get the interest, that's the simple interest, you add it to the capital. So it is the capital I have kept here. That is the 1 million. Now I'm going to calculate the simple interest on it and then add it to the capital. Now the simple interest is what? Principal times time. So the principal is still 1 million times the time, which you don't see here because it is 1. And I know even if I multiply by 1, it will still be 1 million. So I didn't bring the 1. Times the rate, which we don't know and we have represented by R. So that is the R you see here. Have you gotten it now? Hello, the one who said he didn't understand it. Hello, are you there?
Yes, sir.
No, I mean the person, somebody said she didn't understand and I was explaining to her.
So it was Afode.
And now
Afode. I think she's off. She's
Afode,
gone. Yes, I think her network. So she's probably gone now.
She will come back and bring us back again. Mr. Afode, are you back? Lie. Let me give her some few minutes to come. This is the problem with this online thing. You go and then somebody will come back and say, my network, can you go back? She's still not back. Okay, let's continue. If she comes back, we may have to come back and explain to her.
Hello, dog.
Yes, are you back?
No, she's not back. Oh, I'm even calling her. It's not connecting. Her network is very bad.
Oh, okay, then we can go ahead and leave her. All right, so let's continue. So, like I was saying, we'll do it. We'll take, if you are solving compound interest, you use simple interest to solve year by year. So we have 2 years. So we'll solve for the first year. Now, it is the interest you calculate and add to the principal each year. So the first year, our principal is the 1 million. So that is what you see here. Plus, we will now calculate the interest, the simple interest for the first year, and add it to the principal. So that is the plus. So the principal is the 1 million you see here. Plus, now let's calculate the simple interest for the first year. The simple interest is the principal multiplied by the number of the duration. So the duration for the first year is 1 year. So times 1 times the rate. The rate is the R that we don't know. So the R for the 1, you are not seeing it here because even if we bring it, it will not change anything. That is why I didn't bring it here. So we have 1 million times the rate, which is R. So that will give us 1 million R. Okay. But we are supposed to add this 1 million R to the principal, which is also 1 million. So this is where the quadratics is coming in. So what do? You see that you have 1 million here, 1 million here. And so 1 million is common. So you can factorize 1 million out. So that is the factorization I have done here. So if I factorize this stage, 1 million comes out. This will be left with 1. And here it will be left with R. So you have 1 million into bracket 1 plus R. That is the first year. So the principal for the first year becomes 1 million times into bracket 1 plus R. Do you understand up to this stage?
Yes, sir.
Yes, Doc.
We have 40 something here. Only few are responding. Silence means consent. So we'll continue.
We understand, Doc.
Yeah,
Thank
okay,
God.
sir.
Okay.
Fine.
Then we'll continue. So we have finished for the first year. Now we'll move on to go and look for the second year. So we are going to do the same thing, but don't forget, if you remember how to solve compound interest, your interest, the capital plus the interest for the first year now becomes your principal for the second year. So we will now calculate the interest on this new principal for the second year and add it to it. Then we get the final figure. So we now come to the second year, and the principal plus interest for the first year now becomes the new principal for the second year. So that is what you see here. 1 million times into bracket 1 plus R. Then we are going to calculate the simple interest on this 1 million times into bracket 1 plus R. So then we'll add it to it. So this is it. So now the interest on it. So that will be what? The principal, which is 1 million into bracket 1 plus R, plus, now we calculate the interest. The interest will be what? This same 1 million times into bracket 1 plus R times the duration for that period, that is for another 1 year. That is why I didn't write the 1, because even if I bring it, it will not change anything. But if you are doing your work, you can add it. So 1 million into bracket 1 plus R times 1, which is the 1 year, times the rate for that 1 year too. So that is the new rate. That is the R you see here again. Okay, so you have to, once again, factorize, because you have something in common. Okay, so you can still factorize. So it is the factorization I did. So according to the problem, the total value, so let me not go there yet. So if you come here, you should be able to factorize. Maybe I didn't factorize from here, but you can decide to take the factorization as well, even though I didn't. So you let me follow what I did. So now this is what I have at the end of the second year. I don't know if you understand at this stage. Do you agree to what I have done, where I've reached?
Yes, sir.
Yes, sir.
Good.
Sir. Yes, sir.
Good.
Yes, sir.
So now, good. So this, what we have gotten here now at the end of the second year should be the total. But because we don't know the value of the R, we cannot tell the exact figure. That's why the question is asking us to find the value of the R. But fortunately for us, the question told us the exact figure that we should have if we should know the value of R. So it means that all this here should be equal to that figure that the question gave us. And the question told us that at the end of the second year, the company will be able to redeem a total of 1,102,500 cedis. Yes. Mr. Emmanuel, is it Kwaku or what? Any? Answer, your hand is up.
Yes, sir. Yes, sir. Sir, can you explain
Please go ahead.
Yeah. Good morning, sir.
Morning,
Can
sir.
you hear me?
Yes, I
Yeah.
can hear you.
Yeah. Thank you. Can you explain the formula again for the second year? Please?
Relax,
Let me
you
go
are
over it
talking
again,
so
because-
fast that I can't hear what you are saying.
Sorry. Please, can you go over the solution again for the second year? I didn't get that
Okay.
side very well. Thank you.
All right. That's fine. So let's go back. Now we said if you follow the principle or the steps in solving compound interest, what you get at the end of the first year, that is the principal plus the interest at the end of the first year, becomes your new principal for the second year. So this 1 million into bracket 1 plus R is our new principal for the second year. So we are going to calculate the interest on this new principal and add it to that principal. So that is what you see here. 1 million into bracket 1 plus R plus, now let's calculate the interest on that. And the interest will be the same 1 million into bracket 1 plus R, that's the principal. That's what you see here, times the duration for that year, which is 1. That 1 I said because it will not change anything. That's why I'm not writing it, but you can write it. So times 1, that's a simple interest equal to principal times time times rate. So this is the principal times time, which is 1 year, times the rate, which is R. So this is the second R you are seeing here outside there. Okay, so this, if you put this together, this is what you get at the end of the second year. We could not get the figure because we don't know the value of the R. That is why the question says we should find the R. So that is how I got that. Are you okay now?
Yes, sir. Yes, sir.
Thank God it's Saturday. So now, this is what, in reality, this is what we should have got. But we don't know the value of R. So we now have to find the value of R. But the question, fortunately, told us the figure that we should have got, should we know the value of R. So it means all that we have done here now should be equal to that figure that the question gave us. Do you agree?
Yes.
Good. So we will just equate this statement here to the 1,102,500 cities that the question gave us. So that is what I have done here. So I've just equated this to that figure. So that's what you see here. Then from here, we can now solve for R. We can now make R the subject by applying our quadratic equation. So we will factorize. We can see something common. So we'll factorize that out. We'll factorize 1 million out. So if you go to the next stage, that is what I have done there. Okay. Yeah. So that is what I have done here. So I have equated to the figure. Then I factor the 1 million out. So if you factor the 1 million out, the person who is writing on my screen, please stop. I'll deduct 150 from your accumulated mark. So be careful, your last warning. So you could see after this stage, I believe you can see where my cursor is. So I factor the 1 million out. So that's what you see out. Then I bring the square bracket. Now, if I take 1 million out here, I'll be left with 1 plus R. So that is the 1 plus R you see here. When you come here, I'll be left with 1 plus R times R. That is what you see there. And that is equal to the figure that the question gave us. Okay. Then, once I do that, I can now solve what is in the square bracket. First of all, I need to expand or remove the brackets. So where there is 1 plus R times R, I have to expand it. So it is that expansion I've done and removed the bracket. So if you take the first bracket in the square bracket, you see that I've removed the bracket, the other bracket. So I am left with 1 plus R. That is the 1 plus R you see here. Plus, now I expand the other bracket. So the R will multiply 1, and that gives us R. And the same R will multiply the R inside the bracket there, and that gave us R squared. So you see that I have removed those brackets there. I'm left with the square bracket. And it's equal to what? The figure that the question gave us. Then, within that square bracket, we group like terms. So if we group like terms, we let it follow the quadratic equation formula. So we have R squared coming first. Then 1R plus 1R will give us 2R. So that's the 2R you see, plus the 1. So that's plus 1. Multiplying the 1 million. Okay, and equating to what? The figure that the expected figure that the question gave us. Then what do? We factorize that bracket. Okay, we factorize it. Now you see, so you have seen the quadratic equation there, R squared plus 2R plus 1. So this is where you have to apply how I taught you to factorize now. You remember that? I hope you have not forgotten. If you have forgotten, then trouble. So if you remember how we did the factorization last week, we are going to factorize r squared plus 2x plus 1. So what do? The coefficient of r squared is what? 1. We'll use it to multiply the 1 here, and we'll still get 1, and we'll keep in memory, or we keep it hanging in the air. Then we'll now look for two numbers that if we multiply, we'll get 1. But if we add, we'll get 2 at the middle there. What are the numbers?
1 and 1.
Two
One,
numbers, 1 and 1. So 1 times 1 will give us 1. 1 plus 1 will give us 2. So we attach r to the 1 and the 1. And then in place of the 2x, we take out the 2x. And then we replace it by the 1r plus 1r. Okay? So that is what you see. So 1r is the same as r. So there's no need to bring the 1 again. So it becomes r squared. See the red here. Let's come back to the red ink. So it becomes what? R squared plus r plus r plus 1. Then you put them into pairs of brackets, and then we factorize. So that's what happened. Okay. So you have your 1 million out, the square brackets. Then we factor the first bracket. In the first bracket, you have r squared plus r. So you factor r out. So if r comes out, you'll be left with what? R plus 1. Is that not it? The same thing, you go to the other bracket where you have r plus 1. What is common? 1 is common. So you factor 1 out, and you still get r plus 1. As for the factorization, I taught you last week. So I'm not teaching factorization today. I'm only applying it. Okay.
So please, can
So
you
if
increase
we
it
do
more?
that, pardon me,
The front, can you increase it more? It's a bit small. It's more of having
the
the size is
uh,
very
it will not go. If I do it, it will go outside. Okay, I think it's okay. Is it clear now?
big. Yeah, this is okay.
Is it okay?
Yes, sir. Yes, sir.
But I started hiding somewhere. Okay. So I left here and I came to the red ink. Okay. So from this stage, eh, I came here. You see my arrow, just to make you explain, understand better. So I came here. So the 1 million out, and then I factorize this. So the coefficient of r squared is 1. I multiply it by 1. I get 1. I keep it hanging in the air. I look for two numbers that I multiply, they give me 1. I add the same two numbers, they give me 2. And you said the numbers are 1 and 1. So we attach r to them and take out 2r and replace them. I replace 2r by those numbers. So that is what you see here. So it becomes 1 million into bracket r squared plus r plus r plus 1, bracket close, equal to 1,102,500. Then I put them into pairs of brackets and I begin to factorize. So that's what you see. So in the first bracket, you have r squared plus r. What is common? R is common. And so we take r out and use it to divide everything in that bracket. Okay? So if you divide r squared by r, you'll be left with r. If you divide r plus by r, you'll be left with 1. So the first bracket will give us r out into bracket r plus 1, bracket close. Plus, we come to the second bracket. In the second bracket, we have r plus 1. What is common? It is 1. So we take 1 out and use that 1 to divide everything inside that bracket. So we divide R by 1, we still get R. We divide 1 by itself, we still get 1. Last week, I told you that the answer you get in the first bracket must be the same as the answer you get in the second bracket. So you could see that they are the same. Since they are the same, we'll pick one of the brackets. So that is what you see here. Okay, so we pick the first bracket, and then we pick those outside the bracket and put them in another bracket. So we have R plus 1. We keep them also in another bracket, and that is what you see here. Now, somebody will say, I said R plus 1, but you are seeing 1 plus R here. Please, they are the same thing. It doesn't change anything. So you can change the positions. It will not change anything. Since it is not subtraction, you can write it anyway. It will not change. So they are the same. Are we okay up to this stage, please?
Yes, sir.
Yes, sir. Yes.
All right. Okay. So now this is the result we have. We are here now. Okay. But you see that it has become 1 plus R or R plus 1 times 1 plus R or R plus 1. So if they are the same thing multiplying, then we will say it becomes, if you have 1 plus 1 times 1, is it not the same as 1 squared? Or 2 times 2 is the same as 2 squared. So 1 plus 1 times 1 plus 1 is the same as 1 plus R plus 1 plus R. The same as what? 1 plus R raised to the power 2. That is 1 plus R squared. So that is what you see here. That's what I have done here. Please, are we okay with that?
Yes, sir.
Okay. So this is equal to the figure that the question gave us. And don't forget, in all that we are trying to do, it's just a matter of trying to make R the subject. That's the rate. That's what we are looking for. That's why we are worrying ourselves. So at this stage, we want to make R the subject. So we begin to group items. This 1 million here need to join the other figure on the right-hand side. How do you get it? It is multiplying. So you can only get it out there by dividing through by 1 million. So that is what I did here. So I divided both sides by 1 million, and the 1 million here cancels out. So we are left with 1 plus R all squared. So that's what you see here, being equal to what? The figure that the question gave us divided by this 1 million. Okay, so that's what you see. Then still, we've still not gotten our R. So we have to continue. Before we can get this R, the square must go. Anytime you have a square, how do you get it out? You can only remove the square by taking the square root on both sides of the equation. Okay, so we have to take the square root on both sides of this equation. So if you take the square root, then the square here will cancel. So that is why you don't see the square here any longer. So we are left with 1 plus R, which is equal to, anytime you take the square root, we have two answers. You get the negative part and the positive side. So that is why you see I wrote plus or minus square root of the figure that the question gave us divided by what? The 1 million. So that's what you see here. So at this stage, you take your calculator and divide and take the square root. So first of all, you must divide 1,102,500 cedis by 1 million. Okay, so you divide. And then after that, you take the square root. Now, if you take the square root, this is the answer you get. The typed answer, the figure was wrong. So the correct answer is the one I've written in ink here. Okay. So this is the answer you get. But don't forget, it is positive and negative. So plus and minus. Okay. So the positive side will be 1 point. Sorry. This will give you what? If you do this, you get 0.5 as your answer. But don't forget, the question is going to be this. What am I saying? Sorry. You get 1.05 as your answer. Sorry for that. You get 1.05 as your answer. So we are now having what? 1 plus R being equal to 1.05. Okay? But we are looking for R, not 1 plus R. So this one here must also go. So we still group like them. The one here will have to go to the other side of the equal sign. Okay? Now it is positive. If it moves, it will be negative. So that is why you see -1 here. Then plus or minus 1.05. Okay? -1 plus or minus 1.05. So now our R is equal to the negative side and the positive side, as you can see here. Okay? So -1 plus 1.05 will give you R to be 0.05. That is our answer to R. Okay, so that is if you take the positive side, we'll get what? 0.5. Okay, 0.05, sorry, for the R. And if you take the negative side, then it is going to be what? -1 minus what? 1.05. And that will give us -2.05 as the rate. But ladies and gentlemen, we know that we don't take negative rate. Nobody, you will not go to any bank to go and take a loan and they will give you a negative rate. Then it's loan. So we will discard the negative and take the positive rate. Okay, so our R value is what? 0.05. That is what the question is asking us to look for, and we have found it. Any question on that? Ladies and gentlemen, this is where we are. Any question?
So, Doc.
No question? Yes, sir.
Yes. Do you remove the one to arrive at 0.05, right?
I did what?
I said, do you remove the one to arrive at 0.05? This last at the end here.
If you say I remove one, I don't want to accept that I remove one. It is the calculation that gave us that.
Okay.
But let me, maybe that is what will make you understand. So let me say I remove it, but let me show you what happened.
Okay.
Look at, we got here.
Mm.
We got here, where we made R the subject. So when this one here, which was with the R, when it moved, it is positive. When it moved to the other side of the equal sign, once it is positive, when it crosses the equal sign, it becomes negative.
Negative, yeah.
So that is the negative you see here.
Okay.
Now, negative plus. So you have -1. You can take your calculator and do it.
Yes.
-1 plus 1.05. So it will remove the 1 and you'll be left with the 0.05.
You are right. I understand. It's a calculation. Yes. Thank you. Thank you very much.
You're welcome. Please, who is talking? Who did I talk to? Is it Fuseni?
It's Ture.
Ture. Oh, okay.
Ture, it's Ture, Doc, please.
All right, that's fine.
Yeah. Yes.
Now, any other question on this? So
Hello,
if
sir.
you have understood, yes, madam. Is it
Sorry,
Afode?
yes, please. My network was not stable, sir, but I'm back now.
Yes.
Sorry.
Yes.
You can
Last
continue.
warning to your network. The last warning to your network. Your network is
Yeah.
warned. So now,
Yes.
do you follow, or we have to go back and take you through?
No, sir. Let's continue.
Are you
I'll
okay
give
with
you
it?
later. Yes, please.
All right. Maybe if after the class too you have to talk, you can call.
Okay, sir.
All right. So that is that. So this is the application of what? Quadratic equation. And like I said, if you go to the actual calculation of a compound interest, there is a simple formula that you don't need to go through this long wahala. But we have gone through this because we are applying quadratics in solving a compound interest related problem, an application question that we are applying quadratics to do. That is why we've gone through this. So if I want to test you on the application of quadratics and I bring this question, I have to restrict you and make sure I put a statement there restricting you to the use of quadratics so that you will not go and take that simple formula and use. So once I restrict you, you can go and take any simple formula. So know how to deal with this. Thank God it's Saturday. So let's continue. Because I have enlightened it. So that is the end of this first. That's the conclusion of last week's work. So you can go and go through the self-assessment questions and then try your hands on them. When I'm ready to give you assignment, I'll show you which of the assignments submit to me. So if there's no question on this, I'll pull it down and then we move on to what the next thing that we have to do. Since there's no question, I'm pulling this down.
Hello, sir.
Yes, madam.
Please, is there a book you could refer us to try more on these kind of questions?
Yes, I gave you the reference material. You saw the reference there. Before I pull it down, there was a reference there. So you can download that book online
Okay.
and you see a lot of examples there.
Mm.
If not, you can, who is this? Ayasemo. Look, I'm in class, so I can't talk now. Call me after maybe, all right. So, Auntie Dinah, I hope I've made myself clear.
Yes, please.
So, you can also take these secondary school books, mathematics books. There are a lot of quadratic equations there and practice. There are a lot of books like that you can use. So that's fine. So let me bring the next one. Please, you alert me when it is time for break. All right. So the next is a continuation of mathematical to 1. And this time we want to look at simultaneous equations for linear functions and linear inequalities. simultaneous equations. So remember your simultaneous equations. So let's look at that. Good. So we are saying that the simultaneous equation system is a set of equations with two or more unknown. The mostly used method of solving simultaneous equation system is the so-called addition, subtraction, or elimination method. You know, we have three methods in solving simultaneous equations. We have the elimination method, the substitution method, and the graphical method. The elimination method, substitution method, and the graphical method. So these are the three methods we can employ in solving simultaneous equations. Let's try to use one of them, maybe the elimination method, and see. So that's what we want to apply here. So let's consider the following example. You have to solve for x and y in the system of equations 3x minus 4y equals 13. That is equation 1. And equation 2 is 3y plus 2x equals 3. Now, if we are using the elimination method, then we have to rearrange the terms in one of the equations so that they will align. Now, if the first one starts with x, let's make sure the second one also starts with x. So we'll interchange the positions of 2x and 3y in the second equation so that the 2x will come first and the 3y will come second. So that is what you see here. That's what I have done here. Okay. Now, before you can eliminate one, so at this point, you will decide whether you are eliminating x or you are eliminating y. So if I decide that I am eliminating x, then I have to make sure that the coefficients of x in both equations 1 and 2 will be the same. Okay, I have to make sure the coefficient of x in both equations 1 and 2 are the same. So now if you look at equation 1, the coefficient of x is 3. If you come to equation 2, the coefficient of x is 2. So how do we make them equal? It's just a simple matter. This one is 3, this one is 2. You want them to have the same figure. So you just use the 3 to multiply equation 2 and use the 2 here from equation 2 to also multiply equation 1 so that if the 2 multiplies 3, it will be 6. If the 3 also multiplies 2 here, it will be 6. Then you have them to be equal. Have you seen that? Hello?
Yes, dog, we've
Yes,
seen it.
Doc. Doc,
Yes,
please go over.
So if you want me to go over, you will not talk. You wait for me to shout before you talk. Then next time I will not shout. I will just be continuing. So if you have a problem, let me know, then I shall handle it. But you will not talk. You wait for me to shout and ask you before you talk. Your last warning. Next time I'll deduct 150 from your accumulated mark. Okay. So I rewind. We have two equations. Or you want me to start from the beginning, then let me go back and start from the beginning. These are the two equations. And we want to use the elimination method to solve. Now, if we are using the elimination method to solve, then we have to make sure the arrangements of the variables in both equations are in the same order. So if you see that the first in equation 1, x comes first. So let's make sure that x also comes first in equation 2. So we have to interchange the positions of x, that's 2x and 3y in equation 2, so that x will come first. So that's what I have done here. So you see that I have brought the 2x first. so that you have all the x's starting. So that's for this portion. Then we want to eliminate. It is at this stage that you want to eliminate one of the variables. Either you eliminate x or you eliminate y. I, in this example, chose to eliminate x. Now, since I have chosen to eliminate x, I have to make sure that the coefficients of x in both equations, equation 1 and 2, are the same. But you realize that in equation 1, the coefficient of x is 3, and in equation 2, the coefficient of x is 2. So they are not the same. So you have to make sure they are the same. How do you do that? If this is 3 here and this is 2 here, and you want them to be the same, why don't we just use 3 in the first equation to multiply equation 2 so that this 2 becomes 6? Then you also take these 2 to go and use it to multiply equation 1 so that the 3 there will become 6. So that is what I have done here. Have you seen it?
Yes, sir.
Now, you don't just use the 2 and the 3 to multiply only the x values. No. Once you decide to use the 3 in equation 1 to multiply equation 2, everything in equation 2 will be multiplied by the 3. The same thing when you take the 2 to multiply equation 1, everything in equation 1 have to be multiplied by the 2. So that is what you see here. So when I use the 3 to multiply equation 2, I multiply 2x by 3, and that gave me 6x. I multiply 9y by 3, the same 3 that I used to multiply the 2x here. I use it to multiply 3y, and that gave me 9y. Then you use the same 3 to multiply the 3 here, and that gave me 9. So that is the equation 4 you see. You do the same. The 2 that you are using to multiply equation 1 will also multiply 3x, multiply 4y, and multiply 13. So that is what you see me doing here. So 2 times 3x gave me 6x here. The same 2 times 4y gave me the 8y here. And then the same 2 times 13 gave me this 26. Are you okay up to this point?
Yes, sir.
Yes, sir.
All right. So you now see that from equation 3 and 4, the coefficients of x in both equations are the same. So once they are the same, you can now eliminate x. If you decide to subtract one of the equations from the other, the x will vanish. So I chose to subtract equation 4 from equation 3. Okay, so if I subtract equation 4 from equation 3, then I'll say 6x in equation 3 minus 6x in equation 4. That takes the x to 0. So that portion vanishes. Then negative 8y in equation 3 minus 9y in equation 4. So it's going to be negative minus 9. So negate, so it will not go to positive. You owe 8 cedis and you have gone to credit another 9 cedis. So you add it, it becomes negative 17y. So that's what you see here. So that's the subtraction I did here. So you have 0 minus 17y. Then 26 minus 9 will also give you 17. Okay, so now we are getting 0 minus 17y is equal to 17. So that gives us negative 17y is equal to 17. You divide through by what? Negative 17. That is what I hid here. That's what I did here. Okay, can you see it? The red ink. So from
Yes.
here,
Yes, sir.
so from here, we are looking for y. So what do? You divide through by negative 17. So that becomes y is equal to positive 17 divided by negative 17. And that gives us what? Negative 1. Okay. Then now you know the value of y to be negative 1. Initially, you didn't know the value of x, you didn't know the value of y. Now you know the value of y. So you go back to the original equation and substitute the value of y to any of them. You choose any of them. I chose the first equation, equation 1. So I went back to equation 1. Wherever I saw y in equation 1, I put negative 1. Okay. So let me take you back to equation 1 so that you see it clearly. Look at equation 1. So I'll come back here. Wherever I see y, because now I know y is negative 1, I will replace y by negative 1 in this equation. Somebody can also decide to use equation 2. You end up getting the same answer. Just that you are not using both equations. You are just coming back to pick any one of the two equations and substitute the value of y in it so that you can solve for the value of x. That is all. So I chose equation 1. You can also choose equation 2. In the end, we'll get the same answer. So if you substitute here, you are going to get 3x minus 4 times, now y is what? Negative 1. So times negative 1 being equal to 13. So negative times negative will give you positive. So it becomes 3x plus 4 is equal to 13. So that is what you are seeing here. Okay. That is what you see here. Then we want to see the value of x. So we'll group items. The positive 4 here will move away. So since it is moving away to join the 13, and it is positive here, once it crosses the equal sign, it becomes negative 4. So that is the negative 4 you are seeing. So it becomes 3x is equal to 13 minus 4. And 13 minus 4 will give you 9. So we have 3x is equal to 9. But we are looking for x, so you divide through by 3. So 3x divided by 3 will give you x. 9 divided by 3 will give you 3. So the answer is that the value of x is 3 and the value of y is negative 1. That is how you solve simultaneously. Any question for me? Do we all understand this approach? Simultaneous equation.
Yes, sir.
Yes, Doc.
Is there anybody who has a challenge that we have to help? Okay. Silence means consent. Thank God it's Saturday. So we move on. When it is break, draw my attention, then we go.
Yes,
Then
sir.
we have to apply. We have to apply this. So everything we do, we'll do the application. But let me be honest with you, ladies and gentlemen. At your level as master's degree students, I must be frank with you. All my questions that I'll give to you are the application questions, strictly. Because all that you are learning here, you are supposed to go to your offices and apply them. So my questions are going to be based strictly on the application questions. So take note. Thank God it's Saturday.
Well noted.
So let's apply, if we have understood simultaneous equations, let's apply it and see how it works. So let's take an example. Let's look at this application question. The question says, suppose a factory manager is setting up a production schedule for two models, Model A and Model B, of a new product. Now, Model A requires 4 units of labor input, and Model A requires 4 units of labor input and 9 units of capital input. Model B requires 5 units of labor input and 14 units of capital input. The total available labor input for the production of the products, the total available labor input for the production of the units of, I say many subrimio. Say minyan didi. When we fufu online bread.
It's just so bad.
The total available labor input for the production of the product is 335 man-hours per day. And that of capital is 850 units per day. How many of each model should the manager plan to make each day so that all the available labor hours and capital inputs are used? So this is a nice application question. Suppose a factory manager is setting up a production schedule for two models, Model A and Model B, of a new product. So once you see the two models, Model A, Model B, so that tells you X and Y. So your simultaneous equation is coming in there. Model A requires 4 units of labor input and 9 units of capital input. Model B requires 5 units of labor input and 14 units of capital input. The total available labor input for the production of the product is 335 man-hours per day, and that of capital is 815 units per day. How many of each model should the manager plan to make each day so that all the available labor hours and capital inputs are used? So, ladies and gentlemen, this is an application question for simultaneous equations. Now, you just translate this into a table, and that will make it easier to solve. So this is a nice table for you. You have the input, that is labor and capital. Now Model A, Model B. Then the equation told you that you have 4 units for labor for Model A, 9 units for labor, 9 units for what? Capital. Then for Model B, you have 5 units for labor and 14 for capital. The total man-hours per day is 335 for labor and 850 units for capital. So this is a summary of the whole question there. Once you are able to bring it out into a table like this, it becomes easier to solve. Now, from this table, we will write the 2 equations. Okay, we write the 2 equations from this table. You write equation for labor and write equation for capital. So that is what you see here. So we let X be the number of produce of model A per day, and Y be the number of produce of model B per day. So that is what we do. So where you see X, it represents A, so that is product from module A. Where you see Y, it represents product from module B. Now, let's write the equations. So if you go to the table, 4x plus 5y will be equal to 335. 9x plus 14y should be equal to 850. So those are the two equations. Then you just use your simultaneous equation that we have just learned to do. That's all. So using the elimination method, if we choose to eliminate x, then the coefficients of x in equation 1 and 2 must be the same. And for that matter, you just multiply equation 1 by 9 and multiply equation 2 by 4. Then you see that they will be equal. So it's not anything that is difficult to do. Once, if you want them to be equal, it's just a matter of using the figure in the first one to multiply the other one. Then you use the other one also to multiply this. That's all. I hope that is clear.
Yes, yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yo. So that is that. So that's what you see on the next page. So that is what has been done here. Now you see that the two equations, the coefficients of x from the two equations are the same now. And so you can eliminate x. So mostly look, because you people don't like dealing with the negatives. When you are subtracting, you look at the highest one and subtract the smallest from the highest one. That's what you always do. So if I look at these two equations, the equation 4 is greater than the values in equation 4 are greater than the values in equation 1, in equation 3. So you subtract equation 3 from equation 4. So that will be equation 4 minus equation 3. That's what you do. I don't know why I wrote equation 1 and 2 here. Please, it's an error. So you can correct it. So it is equation 4 minus equation 3. But in any way, whichever way you subtract, if you decide to subtract equation 4 from equation 3, still you get the same answer. Just that you have to work with the negatives. That is all. So I think I use equation 3 minus 4 here. That's what I did. Okay. So if you do that, it will be what? 36x minus 36x, and that goes to 0. So that's what you see here. I have 0. 45y minus 56y gave me negative 11y. Then 315 minus 3015. Okay, so 3015 minus 3,400. That gave us what? Negative 385. So now 0 minus 11y will give you negative 11y, being equal to negative 385. We need y, but not negative 11y. So what do? We divide through by what? Negative 11. So if you divide negative 11y by negative 11, you are left with positive y because the negative will cancel. You are left with positive y. You divide negative 385 by negative 11. Again, I get 4. The negative will cancel. You are left with 35. So y is equal to 35. So now we know the value of y. You now go back to the original equation 1 or 2. Choose any of them. So you choose any of them. Go there. Wherever you see y, you replace it by 35 and solve for x. So I went back to equation 1, the first equation, and then I substituted 35 for y and solve for x. So that is what you see here. So it became 4x plus 5 times 35. That was 5 times y, that's 5y. Now y is 35. So I replace y by 35 and equated to 335. So that is equation 1. Okay, then you solve for x. So this is what we get. We want to make x the subject, so x must stay alone. And so we take away 175 to the other side. When it goes there, because it is positive here, when it goes there, it becomes what? Negative. So that is why you see negative 175 here. So it becomes 4x is equal to 335 minus 175. And that gave us 4x equals 160. We need x, but not 4x. So what do? We divide 2 by 4. So 4x divided by 4 gives us x. 160 divided by 4 gave us 40. So now we know the values of x and y. X is 40, y is 35. So the solution values are y is equal to 35, x is equal to 40. This indicates that according to the specific constraints, the manager should plan to make 40 units of model A and 35 units of model B. This is the conclusion of the application question. If you don't conclude, you lose marks because the conclusion is very important. That is what the question asks you to find. The question didn't ask you to calculate anything. It asks you to find what values, you have to find the values the manager will need to plan. Okay, let me go to that question. What did the question say? It says, how many of each model should the manager plan to make each day so that all the available labor hours and capital inputs are used? So when you finish solving, come back, look at the question and conclude, give your conclusion, answer the actual question. So now that you know the values, you now come back and say, blah, 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 blah. That is what you have to do. Ladies and gentlemen, if you have any question for me on this, ask me and let me answer.
So I want to ask something.
Yes, go ahead, please.
It only be necessary to put back your 40 to confirm if it actually matches with the 335 to ensure that your answer is correct.
Yes, if you ask me whether it will be necessary, I will say no. But it will be good to test your answers. So it is good. I don't need it as part of your solution, but you can test to ensure that the values you have got are correct before you submit your work. And how do you test? Like just as you have said, the values you have obtained for x and y, go back into the two equations, substitute them. If you substitute, you should get let me go here. If you substitute, you should get 335 in equation 1. So now you have 40. Let me come here rather. Here, these are the two equations. So x is 40. So you come here, put 40 for x. So that will be 4 times 40. That will give you 160. Plus, you come here, y is 35. So put 35 for y. So that will be 5 times 35. Now you put those answers on the left together. If it is equal to the answer on the right, then you know your value that you have got is correct. You can do the same for the second equation too. If you get the figure on the right-hand side, then you are sure that the lecturer cannot mark you wrong. Your answer is correct. But you are not submitting that to me. It's something you can do as rough work somewhere to check. I don't need it. So you are right. It's good to do that. I hope I've answered.
Yes, sir.
Any other thing, please? Ask your questions. So, one day I'll ask you. If you don't ask and the day comes, I'll ask mine and add yours that you should have asked me that you didn't ask, and I'll add that one too, so that the question will be nice. So if there's no question, let me continue. The Nepal, no question there. Now we come to functions. Functions. Now, what is a function? A function is, oh, sorry, what did I say? I said it should be linear functions. Now we are looking at linear functions. Then what is a linear function? A linear function or a function f is said to be a linear function if f of x can be written in the form f of x is equal to ax plus b. I think last week we talked about linear functions, so this is not new to you. But just that you must make sure that the coefficient of x here is not 0. Because once the coefficient of x here becomes 0, it ceases to be a linear function. It ceases to be a linear function. So take note. The function y equals to f of x equals ax plus b is an equation of a straight line with slope a and the y-intercept b. Ladies and gentlemen, anytime you see f of x is the same as y. So in place of f of x, you can write y is equal to ax plus b. They are the same, they mean the same thing, they refer to the same thing. Now, if you should draw the graph of this straight line, you see that the coefficient of x becomes the gradient of the straight line. And this b here is the point on the graph at which that straight line will cut the x-axis. Sorry, the point on the graph at which the straight line cuts the y-axis, not the x-axis. So that point, anytime you draw a straight line, I don't have my pen here, I would have written it for you to see. But if you see any straight line graph, the point at which that straight line cuts the y-axis is the b value. That is the value for b. That is what we call the y-intercept, or the intercept on the y-axis. Okay, so you must always say it. The number which, anytime you write the equation of a line, equation of a straight line, the figure that multiplies the x is the gradient. So we say the coefficient of x is the gradient. And then the constant, which is the b, is the y-intercept, the point at which the graph or the straight line cuts the y-axis. I hope that is clear. So let's look at some examples. Suppose f is a linear function with slope of 2 and f of 4, f of 4, f into bracket 4 is equal to 8. Find f of x. Okay, find f of x. So once you see that it has made a statement clearly that it is a linear function, so you have to write, the formula for a linear function, so you have to write the formula down. So the linear function is of the form f of x equal to what? Ax plus b. is constant. It doesn't change once it is linear. So it's of the form ax plus b. Now, the question has given you the a, that's the slope. From the previous slide, I mentioned that the coefficient of x, or the number that multiplies x, is the gradient. That's the slope. Gradient is the same as the slope. So the question has given you the slope to be 2. Indirectly, that is the value of a that the question has given to you. Okay. And it has given you f of 4 to be 8, meaning f of x is equal to 8. Sorry, I will not say f of x is equal to 8, but at the initial stage, it means ax plus b is equal to 8. That is f of 4. We don't know f of x, but we know f of 4 to be 8. So ax plus b is equal to what? 8. So that is what you must take note of. So a is the gradient or slope, that is 2, given by the question, and f of 4 has been given to be what? 8. Okay, so but you know that f of x is equal to what? Ax plus b, and now a is what? 2. So if you are giving f of x, it looks like f of x. So f of 4 should be equal to what? 2 times 4 plus b. So your 8 is equal to 2 times 4 plus b. So, and 2 times 4 is also 8. So you have 8 is equal to 8 plus b. So you can make 8 be the subject from here. Now, if you make b the subject, that will be what? The 8 here will leave the b and go and join the colleague 8 on the other side. Right? As it goes, it is positive here. When it gets there, it becomes negative. So that's why you see 8 minus 8 equals to b. And that's what I've written here as this. And so b will be what? 0. Now you have to find f of x. But we know that f of x is equal to 2x plus b. Ax plus b, sorry. F of x equal to ax plus b. But the question has given you a to be 2. So 2x plus b. But you have calculated b to also to be 0. So it becomes 2x plus 0. And so your f of x is what? 2x. Any question on this, ladies and gentlemen? Ladies and gentlemen, any question? Silence means concern. Thank God it's Saturday. We continue. Today the number has increased. Last week we were 30 what? Okay, if I go and check my attendance, I'll see. And today I can see 40, 41. Who were those who were absent last week? If I check my attendance, I'll see them. So they have lost 1 mark. So they are scoring 9 for now. So if there's no question, let me move on.
Hello, sir.
Yes, madam.
This is
Hello.
yes, sir. It's time for break. 30
Oh, it's
minutes
time
break.
for break, eh? Oh, okay, break time. Crank, crank. Break, please. So let's go and come. When are we coming back?
10:30.
10:30.
Okay. So go and come. Bye-bye. is 0 day. So the number of days there is 0. So for equation 1, have what? 4 kilograms is equal to B, because M times 0 will give you 0. So 4 kilograms is equal to B. That is equation 1. So that's what I've explained here, that at the beginning, D is 0 and W is what? 4 kilograms. Okay, so if you want to see it, 4 is equal to M times 0 plus B. Okay, M times 0 plus what? B. So that is what you see. That is what you see. So which implies 4 is equal to what? B. That is equation 1. Then 25 days later, the weight of the hen was 7 kilograms. So 7 should be equal to what? M. So now the day is not 0, it is 25. So the day D is 25. So you have 7 is equal to M times 25 plus B. So that gives you 7 is equal to 25M plus B. That gives you your equation 2. Okay. Then we solve this simultaneously. Now we have equation 1 and equation 2. We solve it simultaneously. But you could see straightforward from equation 1, B is equal to 4, direct. So you just come and substitute B is equal to 4 into equation 2 so that you can look for your M. Okay, so that is what has been done here. Okay, so substituting B into equation 2, where you know B is equal to 4, we have 7 is equal to 4 plus 25M. Please don't be confused if you are following me here. If I write B plus 25M is the same as 25M plus B. And now the B is 4 from equation 1. So in place of B, we put 4. So 7 is equal to 25M plus 4. It's the same as 4 plus 25M. So that's what you are seeing here. Then we make M the subject. So how do you make M the subject? We need to group like terms. So, sorry. So we need to group like terms. So these 4 will join the 7 there. But don't forget, the 4 is positive here. So if we move to join across the equal sign, changes to negative. So we have 7 minus 4 being equal to 25M. So that gives us 3 is equal to 25M. We are looking for M, not 25M. So what do? We divide 2 by 25. So 25M divided by 25 will give you M, or the 25 will cancel out. Then, so M will be equal to what? 7 divided by 25. Wait, did I say 7? It's 3 divided by 25. So M is equal to 3 divided by 20. If you take your calculator and divide, please mute yourself. Mute yourself. Minus 150. Okay. So we have 7 minus 4. That will give us 3. So 3 is equal to. Please mute yourself. If you are not talking to me, mute yourself.
Ihe 5
Dog, I think it's Emmanuel.
Emmanuel,
you are disturbing the class.
Weekend then no, Saturday no. Cool.
Emmanuel, please unmute yourself.
So we have 7 minus 4, that gives us 3. And so we have 3 is equal to 25m. We divide through by 25. So we have m being equal to 3 divided by 25. That is, if you divide through, now you have 3 is equal to 25m. So if you divide through by 25, you are going to have 3 divided by 25. That gives you 3 over 25. Then 25m divided by 25. The 25 cancels out. We are left with m. So that is what you see here. And if you take your calculator and divide 3 by 25, you get m to be 0.12. 0.12. Okay. Therefore, the linear function can be written. The first question says you write what? Let me take you back to the question. Let me take you back to the question. The question says you should determine W as a linear function of D. So let's write the linear function. So now that we have found M, and we go back to the function and write f of D is equal to what? Here. It is only the M that you were looking for. So you found the M. So just go back and substitute the 0.12 for M in this function. That is all that the question is looking for. And it has given you the B to be 4. So that one too is there. So it will be only left with the D that you leave in the function. So this is the function that the question wants you to write in terms of W. So W is equal to what? 0.12D plus 4, or 4 plus 0.12D equals W. So this is the linear function the question wants you to write. So all that we were doing from the beginning was to arrive at this. Any question on that before I continue? No question. Thank God it's Saturday. And the second part, let me take you to the question once again so that we look at the second part. The second part says, what is the average weight of a hen for a 10 days period? This one, once you have written the linear function in A, it is just a matter of going back to the linear function that you have written for A. Where you see D, you substitute 10 for D and solve. That's all. So the main work is what you have done in A. So the B is just a matter of going back to that linear function that you have written, substitute 10 for D in that function, and get the actual figure. That's all. So let's see how that worked out. So when D is equal to 10 days, the average weight after 10 days for the hen is going to be what? You just copy this function, W or f of D is equal to 4 plus 0.12. Then the D, in place of the D, you put the 10 days. Okay, so that gives you 0.12 times 10. So that gives you 4 plus 1.2, and that gives you what? 5.2 kilograms. So after 10 days of that feeding, the weight of the hen becomes 5.2 kilograms. So this is how this question can be solved. If there's any question on this, let's bring it up before we move on. But if there's no question, thank God it's Saturday and we can continue.
Okay.
Yes, sir.
So I'm just trying to do some analysis. Okay.
Yes.
From 0 days, the hen had 4 kilogram weight.
Mm.
Then for 10 days later,
Mm.
it moved from 4 to 5.2.
Yes.
Then 25 days later, it moved from 5.2 to 7 kilograms. I think the movement is a bit small as compared to the number of days. That's just an outside analysis that I'm just trying to.
That is right. That's a good analysis. That is right. So the weight of the hen doesn't just change easily like that. It's just piecewise. Small, 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 small. So that is how it is. So your analysis is right. That is correct. Any other thing? Okay. Then we can move on. Now that we are back from break and we are heavy, I wish I can get something that will keep us into action, because people have gone to eat fufu and back, and they are back. If you joke, they will sleep right now. Now we want to look at linear inequalities. I think that is the last topic on this slide. Linear inequalities. Now, if you have understood linear equations, all the processes involved are not different from linear inequalities. The only problem, the only different thing is the fact that, as the name goes, when it was equations, that is equality, so you use the equal sign. When you come to linear inequalities, the name suggests that they are not equal. So you can't use the equal sign here. That is the key thing here. One of the differences that you see here. Apart from that, everything, the steps, the approach, everything is the same. So once you have understood equalities, there is no difficulties in understanding linear inequalities. The other thing under linear inequalities is that anytime you divide by a negative number, the sign changes. So if the original sign is less than or equal to, and then you divide through by negative number, the sign will change from less than or equal to greater than or equal to. So please take note. These are the main two differences between inequalities and equalities. So once you grab this, there is no cause for alarm. So take note. Now, an inequality is simply a statement that two numbers are not equal. It's simply a statement that two numbers are not equal. A linear inequality in the variable x is an inequality that can be written in the form as you can see here. Ax plus b is less than 0, or ax plus b is greater than 0, or simply a is greater than 0. So these are inequalities, as you can see. For example, you are to solve the inequalities 1, 2 into bracket x minus 3, bracket close, less than 4. And 2, 3 minus 2x is less than or equal to 6. So you see that here you don't see the equal sign. No, it will not appear here. So let's solve the first one. 2 into bracket x minus 3, bracket close, is less than 4. So what do? You need to remove the brackets by expanding. So 2 multiply x and 2 multiply negative 3. So that gives us 2 times x, 2x, negative 3, sorry, 2 times negative 3, that gives us negative 6, less than 4. Then we try to make x the subject. So we have to group like terms. So this negative 6 will have to move across the inequality sign. And the same principle applies. Once it crosses, the operational sign on it will have to change. And so you have 2x less than 4 plus 6. So 2x will be less than 10 because 4 plus 6 is 10. Now we need x but not 2x. So what do? We divide through by 2. So we have 2x divided by 2. That gives us x. And 10 divided by 2, that gives us 5. So this is the answer to the first question. Any question, ladies and gentlemen? So we understand this. So let's look at the second example. We have 3 minus 2x being less than or equal to 6. So once again, we want to make x the subject. And so we'll group like terms. 3 here, we'll have to move across to the other side. And once it crosses, it becomes negative. So you have negative 2x left here, being less than or equal to 6 minus what? 3. And that gives us negative 2x being less than or equal to 3. But we need x, not negative 2x. And so we have to divide through by negative 2. Now, if we divide through by negative 2, negative 2x divided by negative 2 give us positive x. Then 3 divided by negative 2 should give us negative 3 over 2 or negative 1.5. So I didn't bring the, it is there. I think I've written this sign across it. So the answer is negative 3 over 2. Why? Negative 3 over 2. And it should be what? The sign, you see that the sign has changed here. It was less than or equal to, but because we divided through by negative 2, the sign has changed from less than or equal to greater than or equal to 3 over 2, which is the same as 1.5. Any question? Okay. So note that the reverse in inequality sign is due to the negative effect, as I've explained. So this answer is negative what? 3 over 2 or negative 1.5. So take note. Then, as usual, we need to apply this. Need to look at the application to this. So let's look at the application question here. The current ratio of any business organization is the ratio of its current assets to its current liability. The current ratio of any business organization is the ratio of its current assets to its current liabilities. The managing director of ACE Equipment Company has decided to obtain a short-term loan to build up inventory. The company has current assets of 350,000 Ghana cedis and current liabilities of 80,000 Ghana cedis. How much can the managing director borrow if the company's current ratio must be not less than 2.5? Note that funds received are considered current assets and loans are considered current liabilities. So if you look at the question, the current ratio of any business organization is a ratio of its current assets to its current liabilities. Now, the managing director of ACE company or equipment company has decided to obtain a short-term loan to build up inventory. The company has current assets of 350,000 and current liabilities of 80,000. How much can the managing director borrow if the company's current ratio must be not less than 2.5? So that is where the less than or equal to or the inequalities are coming. Don't forget the mention of the word ratio. That means something over something. That is current assets divided by current liabilities. So that should be your clue. Now, in handling this, you let X be equal to the amount to be borrowed. The amount to be borrowed. So that is what we are going to look for. Because how much can the managing director borrow? So we are going to look, if we have represented that by X, it means what we are going to look for is X. Now the current assets is 350,000 plus X, okay, plus the amount you are going to borrow. Because if you borrow, it comes to add to your asset. Then current liability will also be 80,000 plus X. That's the loan that we are going to take. And once you take the loan, even though you take the loan, they give you money which you add to your asset, it also adds to your liabilities. So still we add the X to the liabilities. So that is what you see. Now, by definition, as I explained earlier, current ratio is current asset over current liabilities. So now you have stated all of them here, and so you just pick them and divide. So it's going to be 350,000 plus X divided by 80,000 plus X. So that is what you see there. But this should not be less than 2.5. So this is the symbol we are using for that. So that symbol you see there, let me enlarge this. So that is the symbol we are using for that statement. So should it be less than 2.5, blah, blah, blah. So that is what you see. Then with this, once you put this there, then we can now solve the inequality. Can now solve it. So we get what? You have to remove the denominator, the fraction must be removed before you can solve. How do you remove it? You multiply through the expression by the denominator 80,000 plus X. So you multiply the whole left-hand side by 80,000 plus X. And then you also multiply the right-hand side by 80,000 plus X. So that is what you see here. On the left-hand side, if you multiply by 80,000 plus X, this 80,000 plus X will cancel out. That's why you'll be left with what? 350,000 plus X. So that's what you see. Now, this goes to multiply 2.5. So that's what you see on the right. The rest is now for you to what? Simplify. Group items where possible, where you have to subtract, where you have to add, and where you have to divide, you divide. That is all. So once you're able to make this statement up here, your work is done. We only equate it to this, and then the rest is change of subjects. so that you make X the subject. So that is what you see happening here. Okay. That is what you see. So from here, we just expand where we have to expand. So that is what you see. 2.5 times 80,000 gives you 200,000 plus 2.5 times X. That is what gives you this. Okay. That is what gives you that. So from here, after we have expanded it, what do? You take this X, we are trying to group items. So we move this X from the left-hand side. Let it join the 2.5X. There seems to be some double X here. It's a mistake. So you cross it out. Okay. So this X will now move to join 2.5X here. This 200,000 will also move to go and join 350,000 there. Okay, so that's what you see. So now this becomes what? Or if you follow what I did here, semi-critical. Semi-critical.
Iris,
Mute.
Iris, please mute. Iris.
And there's 150 for you. What? All right. So let's continue. So from here, I move you here to the red ink. Okay, to simplify things for you. So don't forget this X here is not part. You can cross it out. So from here, from there, I brought you here. So where I said you group items, the 200,000 goes to join this 350,000. Don't forget it is positive here. So when it moves, it becomes negative 200,000. This X is also positive. When it moves, it becomes negative X. So that is what you see here. Now, if you subtract this, you have 150,000 left, which will be equal to what? If you subtract this from this, that gives you 1.5x. That is 2.5x minus 1x. That gives you 1.5x. So we are making x the subject. What do? We divide through by what? 1.5. So if you divide 1.5x by 1.5, it cancels the 1.5 and you are left with x. Same way you divide 150,000 by 1.5. And that is what gives you this 100,000 here. Then you can now conclude. The managing director can borrow not more than or as much as 100,000 and still maintain a current ratio of not less than 2.5. That is all. So this looks more simpler even than the previous example, if you ask me. Any question on that? Any question? So if there's no question, we move on. Silence means consent, maybe. Then there's another example here. Nice question too. It says a publishing company finds that the cost of publishing each copy of a magazine is 0.38. The revenue from dealers of the magazine is 0.35 per copy. The advertising revenue is 10% of the revenue received from dealers for all copies sold beyond 10,000 units. What is the least number of copies which must be sold so as to have a positive profit? So this is a question for us. And I think today too, once we finish this slide, I will not continue, because the more I pile up there, the zero my work becomes. Everything will be lost. So I will not allow that. So after this slide, we'll close. Whether it is time or not, we'll close. So a publishing company finds that the cost of publishing each copy of a magazine is 0.38. The revenue from dealers of the magazine is 0.35 per copy. The advertising revenue. Hello. Oh, early Monday next week. Then Monday Thursday. Avoid your Thursday as a Friday. Avoid your number class. Sorry. All right, let's continue. The publishing company finds that the cost of publishing each copy of a magazine is 0.38. The revenue from dealers of the magazine is 0.35 per copy. The advertising revenue is 10% of the revenue received from dealers for all copies sold beyond 10,000 units. What is the least number of copies which must be sold so as to have a positive profit? So, what do we do? Once we say what, it means we don't know something. So we represent what we don't know by X. So we let X be equal to the number of copies to be sold. Let X be equal to what? The number of copies to be sold. So X represents the number of copies to be sold. So we are going to find X. Once we put it there, we'll find it. We'll look for it. So that is what we are going to do. Then we should also know that by definition, as we stated last week, profit is equal to revenue minus cost. Revenue minus cost. And so, what is our revenue? Our revenue, R, is equal to what? The revenue from dealers plus the revenue from adverts. Revenue from dealers plus revenue from adverts. Now, if you look at the question, it tells you that revenue from dealers is 0.35 Ghana cedis, 0% of the cost per copy. Okay, 0.35 per copy. So the revenue from dealers is 0.35 Ghana cedis of the profit. Okay, and then the revenue from adverts is also 10%. Is that not it? Yes, 10% off. And so 10% means out of 100. So you divide the 10 by 100. That is what gives you the 0.10 here. 10 divided by 100%, means out of 100. So anywhere you see percent, the symbol is 10 times 1 over 100. So 10 over 100. So you get 0.10. Of what? The revenue from dealers times the total amount, 10. You should not go beyond 10 units, 10,000 units. So you subtract that 10,000 units from the profit. So that is what you see here. So now that you have that, now we also know, so that is for the revenue from, so we have revenue from dealers and revenue from what? Adverts. Then we come to the total cost. The total cost is also what? 0.38 of the profit. Okay, 0.38 of, and am I saying profit? That is number of copies sold, sorry. 0.38 times the number of copies sold. So that is what you see. I was all along mentioning profit. Sorry for that. So X is the number of copies sold. So wherever you see X, we are referring to what? The number of copies sold. So that is it. So now that we know the revenue, so revenue is what? Revenue from dealers plus revenue from adverts. Now we know them. Revenue from dealers is 0.35 times the number of copies. Revenue from adverts is also 0.1 times 0.35 times the number of copies minus 10,000 what? Units. Then we know the total cost also to be 0.38 times the number of copies. Then we can now go back into the formula, fix them in, and solve for the x. Okay. Now we know that profit should always be greater than what? 0. So it shouldn't be less than 0. So that is where the inequality comes. So we substitute all this and make it greater than what? 0. So R is going to be 0.35x plus 0.10 into bracket 0.35 times x minus 10,000 units. So that's what you see. Then minus the cost. Minus the cost. And the cost is what? 0.38 times the number of copies. And that should be greater than what? 0. Okay. So from here, we can now solve for our x. So once we have the inequality, we can solve for the x now. Now, what do? You have to expand that bracket there. Let me take you back here. You have to expand this bracket. So 0.35 will multiply x, and that gives you 0.35x, just as this. The same 0.35 will multiply 10,000. So that is the expansion you are seeing here. So that has been done here. Then you still have another expansion to do because you still have another bracket. So 0.10 will also multiply 0.35x. And that gives you this value here. The same 0.10 will multiply 3,500 negative. And that gives you this value here. So now we have finished with the expansion, and so we can continue. This value, we picked it from there. We didn't do anything about it. We didn't do anything about it. Greater than what? 0. We are only trying to what? Solve for what? X. Class no providing. So we are only trying to solve for x. Okay, so from here, we'll solve for group like terms and solve for x. So all those with x will stay at one side. All those without x will also stay at a different side of the inequality sign. So we keep all the x's on the left and take those without x's to the right side of the inequality sign. So that is what you see here. So from here, we have 0.35x plus 0.035x minus minus 0.38x. So these 3 will stay on the left-hand side. And then we have 350 cedis that will have to move to the other side of the inequality sign. So that is what you see here. Apart from this, the rest are all there. But don't forget, when the 350 was moving, it was negative. Once it moved across the inequality sign, the negative ceases to be negative, but changes to what? Positive. So that is what you see. So now if you simplify the left-hand side, 0.35x minus 0.035x, 0.35x plus 0.035x minus 0.38x gives us 0.005x. And this must be greater than what? Positive 350. From here, you know, we are looking for x, but not 0.005x. So that 0.005 must leave the x alone. How does it leave? You need to divide, since it is multiplying, you need to divide 2 by that 0.005. So divide 0.005x by 0.005, and that will cancel out and we'll be left with what? X. Then we also divide 350 by 0.005, and that division will give us 70,000 there. And for that matter, X is greater than 70,000. And so the total number of, don't forget, we represented X by the number of copies sold. Okay. And so the total number of copies to be sold must be greater than what? 70,000. And that is at least 70,001 copies to be sold. So this is the application question for what? Inequalities. Any questions here, ladies and gentlemen? Any question?
Yes, sir. Yes, sir.
Yes. Yeah. If there's a question, bring it up. If not, we are closing. If you
Right.
don't bring the question up early, close and leave your question. So go ahead.
Please, please, can you go over this again once, just once? How we got the.
Oh, I should go over the.
Yes.
I should go over the from where or the whole solution.
Yeah, no, yeah, from actually the profit from the net X number of copies to be sold. By definition, I want
Okay.
to give that to up to the profit
Okay.
level. Up to what yeah.
All right. So the question says that a publishing company finds that the cost of publishing each copy of a magazine is 0.38 cedis. That is the cost of publishing a copy. Now, the revenue from dealers of the magazine is 0.35 cedis per copy. So the production cost per copy is 0.38 per copy. Now, if you give it to dealers to sell, they get a profit of 0.35 per copy. That's the revenue they get. Okay. They sell each copy and get a revenue of 0.35 from it per copy. The advertising.
Did you say revenue or profit?
Oh, am I saying profit?
Yes, you said profit.
Don't mind me. I'm ready to close. All right. Thank you for prompting me. So the cost of production of each copy is 0.38 cedis. Then the revenue is in two ways. Don't forget. The revenue is in two ways. One of the ways of getting the revenue, one way is from dealers who also get a revenue of 0.35 per copy. The other side of getting the revenue from each copy is from advertising. So when they advertise, the revenue they got was 10% of the revenue received from dealers for all copies sold beyond 10,000 units. Okay, beyond 10,000 units, they get additional 10% of the revenue received from dealers for all copies sold beyond 10,000 units. Now, the key point is that we are asked to find the least number of copies which must be sold so as to have a positive profit. Okay, so that is what we are to look for. So what we are to look for, because we don't know it, in mathematics, anything we don't know, we represent by a variable. And I don't know why. We always like the X and the Y. So because we don't know the number of copies and we are being asked to look for that number of copies, we'll represent that number of copies that we don't know by X. So that is why we let X equal to the number of copies to be sold. So that's how we started. Then we also know, because we are talking about positive profit, we know that by definition, profit is equal to revenue minus cost. Profit is equal to revenue minus cost. But we also know from the question that the revenue is in two parts: revenue from dealers and revenue from adverts. So for R alone, there are two things combined. It is only C which is standing alone. So now the work we have to do is to look for revenue from dealers and revenue from adverts so that we can go and substitute into the formula for profit. So that is what we did. So now let's look for revenue from dealers. The revenue from dealers, if you read, it says is 0.35 Ghana cedis per copy. Per copy. Now this copy of the whatever, is it a book or whatever, we don't know. So this copy is what we don't know, and we have represented by X. So per copy, so that is times X. So the revenue from dealers is going to be what? 0.35 times X. And that is the same, that will give us 0.35X. So that is what we have written here. Then also, we need revenue from what? Adverts. And the question is saying that it is 10% of the revenue received from dealers. Already we know that the revenue received from dealers is 0.35X. Okay. So revenue received from dealers for all copies sold beyond 10,000. So it means we have to subtract the 10,000 from whatever you get, whatever quantity you sold. You have to subtract 10,000 from, because if you sell exactly 10,000, there is not going to be that 10% calculated on your revenue. But if you sold beyond 10,000, assuming you sold 20,000, then we have to subtract the minimum 10,000 from the 20,000. So the 10% will be calculated on what is left and added to your revenue for you. So that is what you must understand there. Sold beyond 10,000. So if you sell exactly 10,000, that 10% will not come. That 10% revenue will not come. But if you sell beyond 10,000, then we'll subtract that basic 10,000 from whatever quantity you sold before we calculate the 10% on the remaining one for you as part of your revenue. So that is why you see that, because we don't know the total sold and we've represented that total by X, we have to subtract the 10,000 minimum from the X. So that's why we subtracted 10,000 from this X before multiplying by the 0.35 and the 10%. So that is what you see here. So now we know our revenues from dealers and the adverts. If you put the two together, we get our total revenue. Then we subtract the cost. So that is what you see here. So the profit is equal to what? The revenue from dealers, 0.35X, plus the revenue from what? Adverts, minus the cost. And the question says we want to get a positive profit. If it is positive profit, then it must be greater than 0. If the question had mentioned negative profit, then it should be less than 0. So anything greater than 0 is positive. Anything less than 0 is negative. So the question says positive profit. That is why we use greater than 0. I hope that is clear. So once we get to this point, we have formed our inequality. So we keep the profit aside, and then we deal with our revenue and the greater than 0. So that is all. So the key thing is you being able to come out with the inequality. Once you get the inequality, the rest is what? That's a simplification. Where you have to expand, you expand. Where you have to simplify, add, subtract, you do. That is all. So from this stage, it is what? Simplification. So in the square bracket, we had to expand the other bracket within the square bracket. So we did the expansion first. 0.35 multiplied x, and we had 0.35x. The same 0.35 multiplied 10,000, and we had 3,500 or something. So that is on the other page. So let's go there. So this is what we got, 3,500. Now we still have the bracket there. So we have to continue with the expansion with the 0.10. So we have to multiply 0.10 by 0.35x, and that gave us this. We multiply 0.10 by 3,500 negative, and that gave us 350. Then we subtracted the costs, and then we added the revenue from dealers, and then we subtracted the cost, and greater than 0. So from all these stages, it is just simplification that we are doing. That is all, nothing else. The main issue had been settled at the time we completed the formation of the inequality. So that is all. Should I continue, or now you are okay?
Sir, please, can you go back to the slide before this one?
Thank you. I'm there.
Where we wrote revenue from adverts.
Yeah.
So we are saying it's 10%
Yeah.
of I'm coming. 10% of revenue received from dealers of all copies sold. So this one, can it be written this way?
Don't stop there. Of all copies sold beyond 10,000 units. That is the key point. So that is why I was explaining that beyond the 10,000, it means if you sell less than or exactly 10,000 units, this particular 10% revenue will not come to you.
Okay.
Have you seen it?
Yes, sir.
That's
where the confusion.
So the 10,000
That is where the confusion is.
The 10,000 units is the basic. That is, let's take it as those like commission, those who work on commission basis. So you have a limit, a basic limit. That is what you are paid. They pay you something small for. Then if you work beyond that, if you bring revenue beyond that, then they pay you additional revenue on a certain percentage. So that is what is happening here. So the normal revenue is for the 3.35 per copy. But the advertising revenue of 10% comes only if your total number of copies sold is beyond 10,000. So
if you
assuming
write the formula, say, hold on, please. So if you write the formula this way, 0.10 into bracket, 0.35x minus 10,000, you get it wrong.
You get it wrong.
Oh, okay.
Because it shouldn't be minus 10,000. You have to multiply the 0.35 by the 10,000 also. You see that there's a bracket there.
Yes.
So that's where you expand. So that is expansion. So that 0.35, which is outside that bracket, will multiply the x
numbers.
Yes, it will multiply both numbers.
The variable and the number.
Exactly. Thank you.
There's a lot of confusion there.
So the point is, you are finding 10% of it. If that the confusion is that beyond 10,000, that is what makes the question critical. So if you don't understand that point, you work and you'll be over the bar, you go over the bar. So because he's telling you that revenue comes if you make sales beyond 10,000 units. So now, what is the X? The X is the total number of copies that you will sell. And now the question is telling you that
beyond
this particular advertising revenue on adverts, will come to you if only you make sales beyond 10,000 copies.
more than 10,000
So,
copies.
yes, so if you sell 12,000 copies, then the 10,000, which is basic, will be subtracted from the 12,000 copies. So the 10% will be calculated on the remaining 2,000 for you. That is why we are subtracting the 10% from the X, because the X is the quantity of copies you sold. So if you don't understand it from this angle, you work over the bar. It's a nice question. Yes, madam.
Please, I have a question.
Yes, go ahead.
From the calculation, the revenue from adverts.
Yes.
So after taking the 10,000 subtracting the 10,000 copies from the X.
Yes.
And then multiplying by the 10%. Why
multiplying
are we
by 10%? Oh.
Yes, the 10%, yes.
Good.
Why are we multiplying by the 0.35? Because
nice one. Nice one. Can I explain?
Yes.
Good. What is the cost, or what is the revenue per copy? The question told you that. Yes. So you are looking for revenue, and the revenue per copy is 0.35. So if you sold maybe 12,000 copies, and so this X is the number of copies. So we take the 10,000 from the 12,000. You are left with what? 2,000 copies. That 2,000 copies is the number of copies. The quantity is not the revenue. So you now have to calculate the revenue on the 2,000 copies. And one copy, the revenue per copy is 0.35. So you have to multiply by the 0.35.
Okay. I get it now.
Well done. Somebody is still writing on my screen.
Yeah, boy, it's your boy, Daniel.
Met 10 or 150. Mr. Yabua, my 150. What is? You already before self-vectorize are no call out the car negative 50. Or the car 50. We try 100% crowd the car 50. Please, any other question before we close? Yes, I remember bell boy now for no crank closing, please. No question. Okay, then. Ladies and gentlemen, next week we have a problem. Is it next week that you have to have face to face?
Yes.
We can meet too. I have a funeral. I'll be at my village. I'm burying 4 people at my village next week. So me, I will not be around.
So we can't even do the online.
No, I want us to get some evenings in the week. If we can meet 2 evenings within the week before Friday. Because we can't miss the lecture. So we have to have the lecture. So let's agree on 2 days. Between that, those 2 days should be from Monday to Wednesday. But from Thursday, Friday, I'm hot. So let's get 2 days.
Okay, sir.
So you decide among yourself and let the course rep communicate to me. From Monday to Wednesday. Hey, did I say Wednesday? Wednesday, so I'm working. Because I have evening. Wednesdays, I close. You see, you are all workers, so we can have it during the day because I don't have lectures from Monday to Wednesday. Monday, the whole day, no lecture. Tuesday, the whole day, no lecture. Wednesday, the whole day, no lecture. Then 5:30 to 9:30, I have lectures. So my lectures begin from Wednesday evening. Unfortunately. So it means we can only use Monday and Tuesday.
So this
Ladies
your
and
Monday,
gentlemen.
Tuesday to be very difficult for some of us.
I accept now
Because
critical.
after, some of us are mad.
Okay, then.
So, please, at what time? On Mondays and Tuesdays, at what time, please?
Definitely it will be after work, after you have closed, because you are working.
Can it be 8 to 10?
We can manage if that is what will be possible.
Because some of us, when the kids come from school, you need to help them with their homework.
Homework.
And all those things before when you put
Because
them to
I could have said we should have it on Saturday morning, just that the 4 hours, if we can get the 4 hours, because I have to be in the funeral. Then unless we start very early, maybe 6 a.m., is that possible? And
yes,
close by 10.
Yes, sir. Yes, sir.
All right. Okay.
Agreed.
Then we can have it the Saturday 6 a.m. and then we can close around 9 or 10. Then I can go for my funeral. So your group, your group there, I don't think I can meet you face to face because all your meeting days, I have funerals. Because even the revision week too, I have a funeral.
Hey,
mercy.
I'm in trouble. From now, in fact, from now to Easter, I'm not safe at all.
But I say, those revision weeks are critical.
Yes, so we'll find a way.
Okay.
Okay, sir.
Either.
So what about Sundays?
But if I am at the funeral.
Oh, okay.
Sunday in the morning.
No, it's not that I am in Okrah. I'm going to the OT region. I'm going to the village.
So network issues.
Oh, no. I mean, you mean we should take the lecture for Sunday?
Early in the morning.
Talking about the in-person meet. I'm talking about the in-person meet.
You are talking about the in-person?
Yes, that was especially for the revision week. I thought probably
okay.
That one, the Sunday would have been, if you are not busy on the Saturday, then the Sunday.
For the revision week.
Yes, for the revision. At least we should meet
Sunday what? Sunday morning.
That is the
sorry.
Oh, Master.
The morning
will,
you see, the morning will not. And you see, this person I'm going to bury is somebody who has been key to my academic success.
Exactly.
It's somebody that review, the one who will be burying during the revision week is somebody who has been key to. If not that person, I couldn't have gone to the training college.
We understand.
Yeah. So I have to go and bury him. Now, if I bury him on Saturday, how do I leave from the OT region?
Online will be fine.
So maybe we'll have the revision online.
Yes.
Or you want to see me face to face?
No, sir,
not really.
Some of us are from a far
You want to
distance.
see face to face.
No, some of us where we
graduation day, you see him, please.
We will even meet during the exam. We'll meet at the exam hall.
Daisy,
yes,
you have forgotten that we need to meet dog in person. You forgotten that we need to meet dog in person. The revision week, we'll be writing exams the following week. You know how dog sets his questions. They'll be there.
And probably with the January intake, we don't even know dog, so we have to see dog face to face.
Those questions are not
okay. Then why don't we do it this way? The week before the revision week, then we meet face to face.
Okay.
Some of us are from far away.
Yeah, some of us are far away.
You can't.
Yeah, but we have to manage, please.
Yes, we need to sacrifice. It shouldn't be convenient.
Most of us are from.
Hey,
anyway,
you can do the online. Those of us that are those of us that are.
Let's
now my network is not permitting me. Please, let's meet on face to face one so that we can recover everything.
You don't worry. You see, the examination. Some of you will be writing in Koforidua and Kumasi and
really?
Kapaso. Yes, some writing Koforidua. Those who are around those places, they write. Those who are around Takoradi, they write in Takoradi.
No, sir, then
Unless,
this time will be the first time. Go for it there, we normally come to Accra.
Oh, you come to Accra?
Yes,
Okay.
please.
But no, yeah, I know
This time the centers have been increased.
Kumasi is Kumasi.
Because, example, last year I learned they were not writing in whole, but this time we are writing in whole.
So then I start for they find out.
All right.
So
Esther, come and write in Accra.
If we so maybe we can, if we meet face to face, then let's meet a week before the revision week. Then that one I'm around. Then we can have it.
A week before the revision week.
Yes.
Then will we get areas? Areas before the
No.
Areas is most important.
Oh, that one is full of shot. So don't
No,
worry.
No, but you know, dog does that one during revision.
So when is the revision week actually?
Dog, please.
The revision week, that is a week to Easter.
Dog.
We'll come.
The week before revision week is the 4th week. And next week is the 3rd week. So why don't we shift
the revision week, the 4th week? Is the revision week not the week not
I
the
think
6th
the
week?
revision week is the 5th week.
Yeah,
It's
so
the
I'm saying
6th
that
week.
no, it's the 5th week. The 6th week
The
is
5th week. Then
for
the 6th
examination.
one was the week of the exam. So
no.
That's how it was last semester.
You are having teaching. No, lectures is 6 weeks.
Yes.
Yes, we are meeting for lectures 6 weeks. So the revision week is mostly the last lecture week. Is that not it?
Yeah.
So that will be that is the 6th week.
Okay.
That's the 6th week. That's the revision week. But then I think you are writing the exams right after Easter. Is that not it?
Yes.
Writing it on 10th.
10th.
10th and
So
11th.
So that is right the following week after Easter. So it means we can't use the Easter week to meet.
No.
So we can only meet during the 5th week, face to face, to do our revision.
So, Dog, why don't we shift next week's meeting, face-to-face meeting, to that last week, so that
that's what he's saying.
The far distance can,
No, but if we meet next week, are we going to have because we did not complete most of the areas as of now.
No, I'm saying that the next week lecture.
Guys, remember Dog is not around next week. We're just complicating ourselves.
That's what I'm saying. So before we meet next week, we have to complete the syllabus first. So that
before we do.
When you don't complete the syllabus,
we have to.
Makes sense.
So we have to finish before we do it.
Yes.
Exactly what I'm saying. What I'm saying is
so
that let us do all the lectures online. Then we meet face to face for revision.
That's all. So that's why I'm saying that we can use the 5th week to meet face to face. That will mop up.
So maybe that is for you because the other lectures, I don't know.
Yes, this one is for me.
For you, okay.
So, we will discuss with second lecturer too, and then you finalize things.
You are having 3 lectures at all?
Yes.
Okay, for June we are having 2.
Oh, you are having 2 for June?
Yes. Please.
Oh, okay. So discuss with this. So discuss with the second lecturer so that it will not be that you have to come twice.
Yes.
So discuss with him that this is the situation. So we should have the revision week on the 5th week.
5th week. So which is 14th, 15th. Is that okay for you? 5th week is 14th, 15th March.
That will be fine.
Oh, okay.
Is it 14, 15?
Yeah, the 5th week is 14th, 15th March.
And the 6th week, no, let me
21st, 22nd.
21st, 22nd.
Yeah,
no,
it's the 6th week.
No, the funeral I think is 26, 27 thereabout.
Of March.
Yes. So we can meet 21st, 22nd for the face-to-face.
That's fine.
That is the 6th week.
Yes.
Okay. Okay.
So I think the revision week is rather the 7th week.
Yes.
So that our last meeting.
29.
Oh, then there's no problem. So our last meeting, our last lecture meeting, we can use it face to face to do our revision and then.
That will be fine.
That's a 6 week.
Okay, very
Yes.
fine.
So that would be better. So those who are far away, come and see Accra. Be a long time since
Some
we
of
came
us
to
know
Accra.
Accra before we moved out of Accra.
No, that's
And
changed.
come again.
Been in
It's been a long
Accra.
time. I also left Accra 2001, February 2001. Now I'm back. And
A
when
lot has changed.
a lot have changed. All the places I used to walk around now, I could not. I came back and I'm seeing everything new.
Yeah.
Brand new.
So come and see Accra.
6 week, 21st,
6
26th.
week. Yes. So we'll discuss that further. So see you next week online from 6 a.m.
Okay.
Remind me. All right. So I wish you
Yes,
well.
sir.
All right, Doc. Thank you so much.
Welcome. Bye.
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 Hi, Papa Sam.
Yes.
Oh, does that mean that next week we'll have online with the man from 6 to 10 and still come to campus for the other lecture?
Yeah, so when we are done, the second ones start at 2 to 6:30.
2 to 6.
So when we are done in the morning, we can travel and go to campus to meet the financial manager market and it's
So when we talk to him, and he can also shift his own to the 6th week.
Oh, that one is not just us. So I think there's some other people parts of that class. So
It's a
that
course.
class were like 100.
Oh, okay. So definitely we have to meet him next
exactly.
week.
The research methodology. So ask her.
And then with the research, since we are going to be on campus, I think Saturday, Sunday.
Next week Sunday.
Can we do the Sunday one in the morning so that those of us leaving Accra can leave after the class?
Normally, don't worry. Normally, they do the only Saturdays, the in person. The Sundays, they normally don't meet on Sundays. The Sundays will be done online. That is what they do.
So we will not meet her face to face.
So
Yeah,
next
on
week
the
Sunday,
Saturday,
no
you meet the face to face, but the Sunday, mostly they don't come on the Sundays. So the Sundays will be done. But I don't know that lecture,
I
so you
think,
have to ask her.
you have
we
to
need to ask
discuss
her
with
first.
her.
You have to ask her.
We need to ask her
Yeah,
tomorrow.
because last semester we were doing 2 courses. Now you guys are doing 3. So maybe
Okay,
you
we
have to
will
discuss
ask her
it.
tomorrow.
So
If
tomorrow
next
we'll
week there
ask
will
her
face to face.
after the class if she can do it. If she's doing face to face, then if she can do it early in the morning, like this one, so that by 12 when we are done, those of us far away can leave Accra
Exactly.
and get home on time.
Sure.
January intake, don't worry, if people are good.
Huh?
I said the January intakes, you are good, don't worry.
We are good. You just can't say we are good.
All right, thank you guys.
Sure.
Bye.
Thank you, Papa Sam.
You're welcome.
I'm going to calm my nerves.
The security and socioeconomic implications here on Prime Insight. Thank you for joining us this morning. But I want us to start off with this whole petition against the Electoral Commission and what the Chief Justice has decided on the fact that there's no grounding for the removal of these individuals. The NDC and the NPP are it again, obviously because they disagree. So here's a wrap for you.
Oh, minimum.